All right, this is a review of a unit for the Unit 3 test, okay? So don't forget to review all the previous assessments, practice and quizzes, meaning all the statistics stuff and the previous quadratics as well. That would be spiral on this test, and the test is this Thursday, okay? Question 1, rewrite each expression in a radical form. So, for example, A, again, radical, 2 goes on the inside, 3 goes on the outside, 2 goes on the inside, okay? B, this negative right here tells us a direction of where this it's going to go. So negative exponent means it's going to be 1 over. So I could write it, if you want it in a steps, as 1 over y to the 4th over a. Okay, now I'm going to change my bottom to a radical form. Again, y goes into the middle, a goes on the outside, and 4 goes on the inside. And that's your final answer. Question 2, rewrite expression with irrational exponents. Now rewriting into an exponential form. So again, 8 comes on a, as your base. All right, now you have a fraction. 3 from the outside goes on the bottom. 2 goes on the top. Same thing for example B. Again, your base is x. Okay, you're going to have a fraction. Again, what comes from the outside, which is 5, goes on the bottom of the fraction. And a 1, which is a not divisible and exponent of x, goes on the top. All right, question 3, it's asking us, select all possible ways to express the number 16 using exponents or roots from the list below. Of course, we're trying to figure out which one equals 16, so 4 squared is 16, so A is correct. Now, root, cube root, raised to a 3rd power, for example, B, you can do it 2 ways. You can turn it into an exponent, so 3 over 3, okay, because the 3 from the bottom goes on outside and 3 is an exponent. So that's just 16 to a 1st power, which is 16. Or we know that anytime that we have a cube root, 16, to get rid of the root, we are going to cube it, and this is what's happening. So that means that we can say that a cube cancels out the cube, which leaves us with 16. So it's still 16. So B is also correct. C, we can rewrite it in an exponential form as 4. Okay, now we have our fractions. So 4 on the outside goes on the bottom and 8 goes on the top. If I simplify that, that's 4 squared, because 8 divided by 4 is 2, which is also 16. So C is also a correct answer. Okay, now let's look at D. D, 2 raised to a 12 over 3. 12 over 3 would be a 4, simplified. So 2 raised to a 4th power is also 16. So D is also a correct answer. Now E, if I rewrite that as an exponential form, this is 4. Again, a fraction. 3 from the outside goes on the bottom. 9 goes on the top. If I simplify 9 and 3, that's going to give me 3. So 4 cubed, it's not 16. Okay, so E is not a correct answer. And then lastly, we have a 2 raised to a 20 on a radical of a 5th power. So again, if I rewrite it into exponential part, 5 on the outside goes to the bottom of the fraction, and 20 goes on the top. 20 divided by 5 is 4. 2 raised to a 4th power is 16. So F is also a correct answer. Okay. All right, moving on. Simplify each expression using the rules of exponents. Leave an answer in exponential form. Now, a lot of students have struggled with example 4 and example 5. Okay. Now, we should remember the rules that anytime we raise anything in the parentheses into another power, that 1/3 will be distributed to both. Okay, so just like if I have a 2 to the x squared, 2 gets distributed to the 2 and the x. Okay. Now, the same thing applies for this example 4. 1/3 gets distributed to both items inside the parentheses. And so far, we have 2 items. We have 64 and we have x to the 15th power. Okay. Now, 1/3 gets distributed to both, which means I got to raise 64 to the 1/3 power and x to the 15 to the 1/3 power. Okay. 64 raised to a 1/3. It's simply a 4 in your calculator. It's also 64 cubed if I rewrite it into a radical form, which is 4 as well, because that's 4 3 times. Okay? Now, what do I do with the x to the 15 power raised to the 1/3? Of course, I'm going to multiply their exponents. So x 15 times 1/3, it's 15 over 3. Now that simplifies to a 5, so my final answer is 4x to the 5th power. Now the same thing applies in the number 5. It's just this time it is vertically set up into a fraction. So that means this too applies to the top and to the bottom. So again, I'm going to raise the top to the 2nd power, and I'm going to raise the bottom, the entire bottom to the 2nd power. Now the same rule applies. On the bottom, I'm going to multiply these two. Okay, so that gives me top stays the same. It is 10 squared. And on the bottom, I'm going to multiply 2/3 times 2. Okay, so that's going to give me 10 to the 4th over 3rd, a fraction of 4 over 3. Now, of course, the rules of exponents, if we have the same base and we have a division, okay, that's a subtraction. So that means I'm subtracting both exponents, 2 minus 4 over 3. Okay, now 2 is a whole number, so for me to change that number into a fraction to be able to subtract it from 4 over 3, I'm going to write it over 1, and I'm going to multiply top and the bottom by 3, okay? Because I want the bottoms to be exactly the same. So now this changes it to 6 over 3, because again, I'm dealing with a fraction. I have a 2 over 1 minus 4 over 3. If I want this one to become a 3, I got to multiply it by 3. If I multiply that by 3, I got to do that same thing to the top. So this becomes 6 over 3 minus 4 over 3, okay? Now, that subtracting it from each other, it's going to give me a 10 raised to a 2 over 3rd power. Okay, and that's your final answer. Now, example 6, again, and biggest mistake students make is forget that this is a square. There is a 2 there, never a 1, okay? So that means I got to convert it and put it into an exponential form. So that's going to be 13 over 2 times 7 over 2. Okay, now again, when we multiply two of the same bases, means y times y, we are going to add their exponents. So this is going to be y raised to a 20 over 2, and then simplified, that's 20 over 2, it's y raised to a 10th power. And that is your final answer. Okay, all right, number 7. Let me make it bigger for number 7. All right, number 7 right here. Again, biggest mistake, students forget that there is a 2 x's with a different tops that are multiplied. Okay, so that means that I need to add their exponents first before I subtract them, okay? So this is x 3 plus 1/2, all right, divided by x divided by x to the raised to a 5 over 2. Now, 3 plus 1/2, again, if I want to simplify their fractions and make their denominator the same, so I'm adding 3 plus 1/2 here. This is over 1. If I want the same denominator, I got to multiply the bottom by 2, which means I got to do the same thing to the top. So this is going to be 6 over 2, now add to 1/2. So that's going to be 7 over 2. So my top now becomes 7 over 2, and that's still divided by x raised to a 5 over 2. Now, of course, another exponent rule is, again, as we dividing two bases of the same basis, we are going to subtract their tops. So x 7 over 2 minus 5 over 2. Okay, so that's going to give me x raised to 2 over 2, which simplifies to simply an x to a first power. All right, number 8. Okay, again, the same basis. I have a division going on here, which means I'm going to be subtracting their exponents. So that's a 1/2 minus a -3. Again, one of the mistakes students forget is that you're subtracting the negative. That means it's going to become a positive. So a now it's going to be 1/2 plus 3, okay, which again is going to be a raised to a 7/2, okay? If you simplified it, this is the same thing as we just did a second ago, okay? 3 and 1/2, so I'm just not going to work it out, but that's 7/2, okay? All right, let's move on to the next one. All right, number 9, again, I got a division here, so I am subtracting their tops. That's a C, 3/11. I'm going to subtract the bottom, which is 8/11. That's going to give me a C raised to a -5/11. And in an exponential form, you would write 1/C raised to 5/11, okay? Or you can leave it with the negative. Again, this negative right here, an exponent, lets me know that it's going to be in a fraction form, the bottom of the fraction. That gives me direction code to go to the bottom of the fraction, okay? All right, let's move on to number 10. All right, number 10, again, you can only work bases that are the same. So A with A, B does not belong. So that means I have a multiplication here, which means I'm going to add their two exponents. So I'm going to just work 4/5 plus -1/5, okay? So that is the only two that I can add together. So that comes up to 3/5. And then B, unfortunately, just carries over because I do not have anything alike. And leaving it in an exponential form, this would be your answer. You can also write it as A, B raised to a 3/5 again. Why? Because if I want to rewrite it, I would distribute it back up. Okay? It is what we did in example 4. And now example 11, again, the top, I need to convert it into an exponential form. So this is going to be a C in the fraction. 4 goes on the bottom and 7 goes on the top. Of course, on the bottom, I have to multiply these two. 3 times 3/4. Okay, so that is going to be 9/4. And now, when they both in an exponential form, I am ready to subtract bottom from the top. So that's 7/4 minus 9/4. Okay, that's going to give me let's see, 2/4, -2/4. And of course, I can simplify and 2/4 to a 1/2. So that's going to be C to a -1/2. And of course, if I want to write it in the correct way, I'm going to write it over the fraction, which is C raised to a 1/C raised to a 1/2. And this would be your final answer. All right. Now, question 12, it says which expression is equivalent to, and again, we have a radical form. We're going to turn it into an exponential form. So B in a fraction, again, we forget that there's a 2 there, not a 1. So 2 goes on the bottom, 10 goes on the top, 12 goes on the top, 2 goes on the bottom. Of course, we are again subtracting 10/2 minus 12/2. Okay, because again, this division means subtracting their exponents. So 10/2 minus 12/2. Okay, that is going to give us a B raised to a -2/2. Now, -2/2 can be simplified to simply a -1. So that's B to -1. And of course, this negative right here now lets us know that that's going on the bottom of the fraction. Okay, and there is only 1 on the top. So the correct answer is A. Number 13, it is asking us, what is the value of the y in the equation? So this, what is the x raised to? Okay, so again, we have a fifth root, x to the 9th power right here, and then x raised to a 3, 3rd power, and now raised to 4/5. Now, we're going to turn it into an exponential form so we can subtract one from another. So again, x, 5 goes from the outside on the bottom, and 9 goes on the top. Now here, of course, again, we are going to multiply 3 times 4 over 5, so that's going to give us 12 over 5. Now, when two bases are the same of x, we can subtract the exponents from each other because we have a division, so that means a minus. So x, we have a 9 over 5 minus 12 over 5. Our denominators are the same, so we can simply subtract it. So that's going to give me negative 3 over 5. Now, should I put it into a form of 1 over x to a 3 over 5? Sure, but that's not what it's asking us. It is asking us what is the exponent, a y value, what the x is raised to. So our answer is negative 3 over 5. So no, we do not need to write it underneath the radical or into a fraction form. It is asking us what is the exponent we're going to be raising x to, and the answer is negative 3 over 5. All right, now question 14. I'm going to show you how to do it algebraically, and then of course, always and always check it in Desmos. All right, so question 14, solve each equation. Our radicals are separated, so there's nothing attached in the front or in the back of the radical. So to get rid of the radical, I can do the opposite operation, which means square the square root. To get rid of that square, that leaves me with just what's on the inside, which is 2x plus 23 equals negative 1 minus x. And now all I have to do is combine like terms. Okay, I do want all my x's to be combined on one side and all my numbers to be on another side. So I'm going to move the x to the right, which is going to cancel out the x on the right and give me 3x here. Plus 23 equals negative 1. Now, of course, I'm going to move the 23 to the other side because, again, I want to make sure that I am combining like terms. So that zeroes out the 23, leaves me with 3x on the left equals negative 24. Now, to solve for x, I'm going to get rid of the 3 by dividing both sides by 3. Now, x will equal negative 8. I'm sorry. All right, now I do want to make sure that I can check that this negative 8 is a solution. I can do it two ways. I can plug it back into the equation, or I can make sure and I check it on Desmos. So I already pulled it out for you guys. So again, one line on one side of the one side of the equation on one line, and second side of the equation on another line. We are looking where two functions will intersect, which is at negative 8 of x value, and that is correct. It is a solution. Okay. Now for question 15. Again, there's nothing attached on the right side around that radical, so that means I can square that, which means I have to square the left. Well, it's going to drop the radical off, which leaves me with 5x minus 9. Well, on the right side, the radical disappears. On the left side, I get x plus 6. Sorry about that. I get x plus 6 squared. That means there's two of them. Okay. That means I'm going to perform a box method or a FOIL to get my answer, okay? Now, if I do a box method right here, I'm going to multiply them out. That's going to give me x squared. That's going to give me 6x. That's going to give me 6x. And that's going to give me 36. Now, when I do put it together, I am going to have x squared plus 12x plus 36 on the left. Now, again, remember, you guys want at all times to put it into the form of a quadratic equation, which means equaling into 0. To be able to do that, I got to move the 5x to the other side, and I'm going to combine it with the things that are alike, which is an x. And I'm also going to add 9 to zero it out, and I'm going to combine it with 36. So now, on the right side, I'm going to have a 0. On the left side, I'm going to have an x squared. I'm going to have a plus 7x, and I'm also going to have 45. Now, unfortunately, this example that we gave you guys does not have two factors of multiply to 45 and give you 7. So this one will have no solutions. You can read that in Desmos because you can't find two factors that will do that. So just plug it into Desmos. Here it is. And you can tell that the functions never cross, okay? So this function we will not be able to get two factors out of it. This is simply going to be no solution. Okay? Very good. now question 16. All right, now unfortunately -2 right here, it's something that is attached to this cube root, and I cannot cube the root unless I move it. So what am I going to do? You guys are going to divide by -2. Divide by -2, okay? To get rid of it, because there is a multiplication between -2 and the cube root. So now the cube root stays right here, which is 5x plus 5. And on the right side, I got -10 divided by -2, which is a positive 5. Now the cube root is by itself, so I am able to cube it to get rid of it, which means I got to cube the right side as well. Okay, this cube will undo the cubicle, so that's 5x plus 5 that's left, and on the right side, 5 cubed, it's 125. Okay, now of course I'm combining like terms, so I'm going to move the 5 to the other side. I get 5x on the left, and I will get 120 on the right. Now, of course, to solve for x, I'm going to divide by 5, divide by 5. So my x will equal 24. Again, I can plug it back in for x into my equation to see if it's a solution, or I can go ahead and graph it. And remember that y right here, okay, the right side of the equation is just -10, which means we gotta write it in Desmos as y equals, because Desmos does not read a simple number, okay? So y equals -10. And again, let me see where they cross. Let's make it smaller. So they will cross right here, which is at 24, which is what we got as a solution. So that is correct, okay? All right. Now question 17, it's next. Again, there is nothing around that radical on the right for me to move, so I'm able to square it, which means I got to square the left side as well. Remember that the 2x squared, that square belongs and gets distributed to both. So I'm squaring the 2 and I'm squaring the x, which is going to give me 4x squared. Now on the right, simply radical goes away, and I get 4x plus 3. Now again, for me to put it into a quadratic formula, which is ax squared plus bx plus c, into a standard form, I meant not formula, okay? And that means I got to move everything to one side. So to keep it positive, I'm going to move everything to the left. So I'm going to subtract 4x, which will zero this out. So I get 4x squared minus 4x now equals 3. And of course, I'm going to subtract the 3 as well, which is going to give me 4x squared minus 4x minus 3 now equals 0. Now I have a quadratic equation. Again, I am going to do a times c method to get two factors, which means I'm going to multiply the first number with the last number, which is -12x squared, and it has to add up to -4x, okay? The two factors that I have found were 2 and 6, okay? So I get 2 times 6, and 6 will be negative to get the -4. So my two factors, x plus 2 and x minus 6. Now, very important that a lot of students have forgotten is the fact that we have a leading coefficient here, which is 4, okay? That means that I got to do bottoms up method. That means I got to divide both of those factors by 4. Of course, this will simplify to 1 over 2. So now x plus 1/2 will be my first factor, and 6 and 4 will simplify and divide it by 2, which is 3 over 2. So x minus 3 over 2. Now, when I do equal them both to 0, okay, the signs will flip, and my answer would be x equals -2, 1/2, and then x equals positive 3 over 2. Now, these are my two solutions. Now, let's plug it in and see which one is extraneous, okay? All right, so again, 2x goes on one line, 4x plus 3 goes in another line. Well, unfortunately, I only got one solution here, which is 1.5, okay? 1.5 out of the two solutions that I have gotten. So let's go back. So that means that 3 over 2 is the only 1.5 is 3 over 2. So that means this is my solution right here. And -1/2 is an extraneous solution. Extraneous, a word extraneous has the word extra in it. That means it's not needed. It won't work, okay? There is another way, of course, to check it. I can take both of these solutions and plug it back into my original equation. So let me show you how to do that. So I am going to take -1/2 and plug it in to this equation right here. So I got 2 times, I'm going to plug in for an x, -1/2 has to equal to a square root of 4 times -1/2 plus 3. All right, so these 2 times -1/2 is just going to be -1 equals, now 4 times -1/2, that's going to be -2 plus 3. Okay, so again, -1 will equal 1, which is not true. Okay, -1 does not equal 1. That's when -1/2 is extraneous solution. I can do the same thing with 3/2. 2 times 3/2 right here. Okay, now it has to equal to 4 times 3/2. Okay, plus 3. Okay, so again, this is going to be 6/2, which is 3. And this is going to be 12/2, which is 6 plus 3, which is 9. Okay, now 3 does equal 3. So 3/2 is my solution. -1/2 is my extraneous solution. And sometimes you guys are going to have a question that we had on the last quiz would it ask you for extraneous, not a solution. Okay, so for the extra one. All right. Now, lastly, number 18 out of this section right here, okay? So again, 18 does have a 9 right here, so I got to move the 9 to the other side first before I can square it, okay? So I get 3x minus 1 here, now equals -1. Now, of course, I'm going to square both sides to get rid of that radical. Now, 3x, which is all what's on the inside is left, equals 1. Now I'm going to add the 1 to both sides to get rid of it so I can solve for x. So that's 2. Now I'm going to divide both sides by 3 to cancel this 3 out. So x will equal 2/3. Now again, I can plug it back into this equation, or I can go to Desmos or do both and check for my solutions. Okay, now when I did plugged in, let me see. It was 8, sorry. It was 8 right here. Okay, when I did plug it in and I made it smaller, all right, they do not meet. Okay, so look, even though I got an answer, those functions do not cross. So that means also no solution. So even though I did get a value of x, this is not a solution. It does not have a solution. Okay. So again, it's very important to make sure that we check for those solutions. Make sure that we check in Desmos, or like I said, plug it back in. Okay. All right. So here, students solved an equation. All right, and this is an error analysis question. So again, you can solve it and follow the steps. Or you can plug it into Desmos to make sure you check. So both of these solutions, so it does look like the person solved it correctly. You know, they moved the -x to the other side first, because again, we want to isolate that radical. So that gave us a negative x equals 2 minus x. Now, of course, we still have a negative here. But when they squared it, okay, well, they divided by negative first. I'm sorry. They divided by negative first. So you had a negative square root of x equals 2 minus x. We divided it by this -1, both sides. Okay. So that means you had a root x equals -2 plus x. I'm going to rewrite it in the proper order. So this is going to be x minus 2 equals square root of x. Now, of course, to get rid of this radical, we square both sides, okay? So this undoes a radical, you get an x equals, and here, of course, you're going to have 2 of those items on the right side, which means you got to create a box method or a FOIL. What you're going to get out of the box method is x squared minus 4x plus 4, which is also correct. So all of these have checked out so far. You are going to move this x from the left side into the right. okay, to combine the x's so it can equal it to 0. So you are going to get x squared minus 5x plus 4, okay? Now the two factors that the student found, okay, that multiply to 4x squared and add to negative 5 was 1 and 4. Okay, they made them both negative to get a negative 5. So the two factors was x minus 1 and x minus 4. Okay, now when you equal it to 0, you're going to get x equals 1 and x equals 4. So these are both solutions. Now, we need to check for extraneous solutions. That means we got to plug it back in to the original equation to make sure it works. So I'm going to go with the first one, okay, which is x equals 1. So 1 minus square root of 1 equals 2. Okay, 1 minus 1 equals 2. 0 does not equal 2. Okay, so I can already say that x equals 1 is extraneous solution. Now let's try 4. Okay, 4 minus square root of 4 equals 2. 4 minus 2 equals 2. 2 does, in fact, equal 2. So the only solution I got for this question is x equals 4. 1 would be my extraneous, which will not work. Okay? All right. All right, question 20. It's asking to identify transformations. Again, you can guys plug it in into Desmos and check how the function behaves. But the outside negative would be a reflection over x-axis. All right. The 2 would be our stretch. It's actually a vertical stretch by 2 to be correct. Now there's nothing underneath the radical other than x, but I got this plus 3 on the side, and that is a shift up by 3. Okay? All right. Now, that's it for this function. Now, question 21. It says which statement is false. So let me make it a little bit smaller so we can see it a little better. So now I am going to go and graph it very quick. All right, so here is the function. Now, I'm going to just read what it says. It's a vertical stretch by a factor of 5. Well, of course, this is my 5 right here. So I already know this is a correct. This is a stretch, okay? So this is a correct statement. I'm looking for a false statement, okay? It says 1 unit right. So that would mean that it's going to be -1, which is also correct on the inside, because remember that this is the opposite. So this is also correct. 6 units down, it's also correct because that's the outside number. So this is going to go down with a negative. So this is also correct. And 1 unit left would be the false statement, okay? Because 1 unit left will be +1, okay? And again, you can play in Desmos by just, if you don't understand what it does, you can do +6 to see where its function is going to go, -6 from the original function, how it behaves. So that might help you as well. All right. Next question. Graph each function, identify the domain and a range. So again, you can guys use Desmos to do that. I'm just going to, so you can see what it looks like. All right, so for this function right here, it was a negative x -1 on the inside and +4, okay? So the function looks like that. This is the point where it starts, which is 1 and 4, okay? So again, 1 and 4 right here. It's a point where it starts, so 1 and 4. And then it does reflect over x-axis, so it's just going to go kind of in this direction, okay? Now, it is asking you to a domain and a range. So again, domain is x-axis and a range is y-axis. So for domain, that's your x, that's your y. So it starts at 1, okay? For domain, it starts at 1, and it travels to the right, okay? So again, x it's going to be greater or equal to 1 because we are traveling to the right. Now for range, again, it starts at 4, and that's a y value. And for a y right here, okay, it starts at 4, and its function is below that 4. So it's going to be less than or equal to 4, okay? Now, for function 23, that is a cubed function, and it is shifted 1 to the left, so somewhere around here. So it's going to look something like this, okay? Something like that. Again, you can go ahead and graph it in Desmos to help you. But again, this should be pretty simple for domain and range, because remember, the domain and range for a cube function will always be all real numbers. It always comes from negative infinity to positive infinity and negative infinity to positive infinity, because it's stretching and continues to go left to right as well as up and down. Okay, it does not stop and does not have a stopping point. All right, now let me move on to question 24, and that's going to be on the next video, okay?